Good afternoon, good morning, good evening, everyone, wherever you are in the world today. My name is Benjamin de Bucher, and I'm the head of events content for JEC Group. Thank you for joining us today. Today's webinar is Manville, Neomera Organosheets, Breaking Barriers to Adoption, an intermodal roof applications re-engineered with Agesia. Manville recently launched a new advanced composites brand called Neomera, with the first products being thermoplastic organosheets. Using JM Neomera Organosheets, Agesia is able to offer innovative yet affordable thermoplastic solutions in application where steel and thermosets products fail. Agesia panels consist of a PET core sandwiched between two JM Neomera organosheets. The continuous production process allows the panels to be formed to shape as well as structural. The panels are suitable for application in transportation, aerospace, automotive, and marine. During the webinar, you'll discover the solutions Agesia has developed and designed for the intermodal container industry and are based around Agesia's new thermoplastic structural lightweight sandwich panels. The solutions reduces the weight of container roofs by 75% and allows the product to perform with deformation under vacuum release. We will be hearing from Danny Decock, Global Business and Market Development Leader at Manville. Danny studied chemical process technology and started his career at Dow Chemical in 1984, where he worked over 20 years in different thermoplastics divisions. He joined Manville in 2005, focusing strongly on new development for long fiber thermoplastic applications. In 2020, his function changed to Global Business and Market Development Leader for the Engineered Product Group, focusing on glass fibers and Manville AP nylon organosheets. We will be also talking to Dr. Dana Miloaga, Product Leader Thermoplastic Composites New Business Team at Manville. In this position, Dana has portfolio development responsibilities for JM new polyamide 6 organosheets and helps advancing new technology platforms. For the last 3 years, she championed partnerships that help JM develop creative lightweight solutions, especially for the automotive industry. Dana received a PhD in chemical engineering from Michigan State University in 2008. And last but not least, we will also welcome Jan Verhage, General Manager at Agesia. Jan is the co-founder and president of Agesia, as well as the president of Agoria Composites. He co-founded Acrosoma and is the inventor of their innovative stitched panel technology. Jan is the current vice president of the European Composites Industry Association and has been a board member since 2003. His accomplishments include development work on the first commercialized composite chassis in the automotive industry. Jan's 30 years experience in structural composites engineering in multiple applications, including transportation, building, and aerospace, make him an exceptional, innovative, and experienced business partner. So, do you want to know more about Neomera's organosheets and how it offers innovative and affordable thermoplastic solutions in application where other materials fail? This will be presented to you in the next 60 minutes during the webinar. Let's discover the benefits of Neomera through a concrete case study application with Agesia. Just a quick reminder before we start, we'll be taking questions at the end of this webinar as usual, so you can ask your question in the question tab here on the right of your screen. And I will be reminding you again during the webinar. Don't be shy and please ask all the questions you have in mind for our panelists today. You have also the possibility to vote the questions from other participants. As usual, I recommend you to be connected through cable wire rather than Wi-Fi to have a better experience of the webinar. And in any case, the webinar is being recorded, so you'll be able to view the entire program later on geccomposites.tv. So let me now open the floor to Danny Decock, Global Business and Market Development Leader at Manville. Danny, welcome online. Could you please give us a little bit of background on Manville?
Thank you, Benjamin, for the nice introduction. A little bit background of Manville. It's a global company. It was founded in 1858, so 163 years old. We have about 8,000 employees, 46 manufacturing locations, 5 technical centers, and 3 billion turnover of annual sales every year. And we are owned by Berkshire Hathaway, so we are not a public company, but privately owned. And our big boss is Warren Buffett. Next slide, please. So Jones Manville has 3 big divisions: the roofing systems, insulation systems, and I'm part of the engineered product group, which is also a split of 4 subdivisions. So we have the fibers for composites, chop strands, direct roving, assembled roving for SMC, for example. We have the non-wovens for several applications, mainly in building and construction, for carpets, for roofing, etc. And filtration and separation systems for, the name says it itself, it's filtration and separation. So, and we have a 4th new one, which is the Advanced Composite Group. And we are proud because we are launching a new product line with this subdivision. And the product line from now on is called Neomera, and it's our Organosheets, what we have today, and what we will explain what we can do with it in this webinar. Next slide, please. Jan, we know each other for about 20 years, I guess.
Yeah.
So you started your career in heavy transportation equipment. You worked a lot of time in metal,
Yep.
different metals, and then you turned to thermoset. You built the first thermoset trailer, and now you're moving suddenly to thermoplastics. So this is difficult to understand because you were a hardliner in thermoset, you had your own company, and now you start a company for thermoplastic applications. So can you tell us a little bit more from that, please?
Yeah. First of all, thank you for having me. When I made my first trailer completely in composite, the chassis completely in composite, I presented it to the godfather of composites at that time, Brand Goldsworthy, the inventor of pultrusion. And he told me, your product will only be successful once it can be made in thermoplastic composites. So since the technology of thermoplastic was not available at that time, I made it in thermoset and was technically successful, but never knew a very big breakthrough in it. Now, when you presented your thermoplastic material, the Neomera, and I tested it, felt it, calculated it, it was clear to me that this could be the solution. And then together with my partner Koen de Roeve, we started Agesia. Agesia started 2 years ago. Maybe we can see the slide, thank you. Started 2 years ago, but grew in the meantime already to a team of 5 highly skilled engineers. We work with the newest technologies to make, test, calculate, and produce thermoplastic composites. So we do the tests on our own test equipment, 3 and 4-point B test, but also we built a very high-powered test bench, which go to 25 tons on 6 hertz, and we measure the composites with optical fibers, which gives us a lot of information. And then last but not least, we developed a panel, and maybe later on we'll talk about a little more.
Benjamin, can we show the next slide, please? Thank you.
So one of our customers, and I call it pull, where Jones Manville is the push, Modalis is one of the leading companies in Europe for intermodal transport solutions, always looking for improvement, technical improvement of his systems and materials. So Modalis had a problem with one of his 20-foot waste containers that we solved. And maybe we should talk a little bit about that, Danny.
For sure, we will do. So Jan, can you tell us, how did you come to Jones Manville? Because yeah, it was known to you, the name, but you didn't know about our product that we would launch.
Well, Danny, we as you told us, you know each other for over 20 years on all the shows and regularly discussions. And as soon as you could reveal technical information about the Neomera product, you showed it to me. And then I started feeling, testing, doing little things with it, but was quickly convinced that this was the way to go further with your product.
Okay, that's great to hear. So would it be possible to tell something about the project as well?
Yes. Can we? This is one of the projects of Agesia. So let's talk little bit of that. And if I can see the video, please. So the problem our customer encountered was by tipping a steel container with a steel cover on it, when the garbage is really wet and it comes out in one block, then it creates an immense vacuum inside in a shock. It's only a couple of seconds, but that destroys the cover, sometimes immediately, sometimes due to fatigue. And so the customer asked us if we could find a solution for that. So continue the video, please. So what we did is combining two problems, or solving two problems. First of all, security, by instead of lifting the complete cover by a crane, we put an automatic system in it. What is new is that we needed a very lightweight panel to be able to reduce the size of the motors and thus also reduce the surface where the garbage or the waste is coming into the container. As you see it here, I am dancing on the roof just to show the flexibility, but also the strength of it. Okay? So what did we do to test it? We installed a test equipment with a vacuum pump of 350 cubic meters an hour, which creates exactly the vacuum that we need. If you see with the steel, it deforms plastically at 20% vacuum. Then we did it with an organosheet of Jones Manville, and with the vacuum bagging over it, and we went up to 60%, which is absolutely out of bounds for this project, but the panel came back without any problem. So if I can see the next video. So the proof of the pudding is in the eating. So here you see the roof with the organosheets, the covers with the organosheets closed, and all of a sudden the waste is coming out very quickly, and you see the organosheet bending to the inside due to the vacuum, but coming back without any problem. So there is no permanent deformation, no plastic deformation, and that is exactly what we are looking for. Due to the fact that the organosheet is also very shock absorbing, that we are very satisfied with the water impregnation in case of rain. This is the ideal combination between Jones Manville and Agesia.
Oh, that's great to hear, Jan, but there are many types of organosheet on the market produced with fabric, but sometimes with tape laying and so on. Why do you exactly choose our product for this application?
Well, you convinced me, since we need organosheets of thicknesses of 3 millimeters and more, and normally on the market you get them with UD tapes, welded in different sizes on each other. So this causes from time to time voids, is not that shock absorbing. You showed it on your presentation. So you have voids, and in case of shocks, these voids cause delamination, and that is absolutely something we do not want, especially not for the further evolution of our technology.
Okay, so is it possible to tell already something about how the project stands today?
Well, the prototype is tested now, and this will go on for several months, but we foresee a market introduction in the coming year with a small series, and then the year after really go into production, not only for containers, but also for trailers.
And how does the value chain look in this case?
Well, we are not cover builders. We will not be the guy who sells the covers. We will sell the technology and the composite around it. So we leave it to the container builder to put all the hydraulics and the steel work in it, and we will deliver the organosheet made in shape, welded to where the places where it will be connected to the hydraulic system.
So, well, that looks good, Jan. It's very interesting. So that is one of your projects. In the beginning of the webinar, you told there are several projects. Can you disclose a little bit of the other projects already?
Yes, we patented a system to weld on very low temperature and very low pressure two types of composites of thermoplastics materials to each other. Here it is polyamide 6 or nylon with PET, and this resulted in a panel that we are now testing thoroughly and with extremely good results. So this panel will replace the cross members and the plywood floor of a trailer or a container, 45-foot container, for example, and saving 1 ton weight on the construction. So nowadays trailers and containers are so, how do you say that, beamed out, that it's very difficult to gain weight. So we make a major step in gaining another weight by introducing thermoplastic composites.
Okay, but in this case, I think you don't only win in weight. I think you can win in volume for the containers as well.
Due to the fact that we replace a steel structure and plywood, we reduce the height of the base of the container, leading to more volume. So the volume space is higher. So that is the aim of the whole project.
So it means you can load much more in a container, higher pallets.
That is the objective.
Okay, that's great to hear. So I think this has also great potential in the market.
Yes.
So, but another question, Jan, to you. You were working with the GM team for a while now. So what's your experience with us? So do we deliver the right GM experience that we always tell what we do? The customer being satisfied, following up with the projects and helping them from the beginning of the project until the realization. Are we doing that?
Well, Danny, we work already, we know each other for 20 years. True. So in the beginning, it's just you and me starting to see what we could do. But very quickly, questions were asked from my side out, and I was not the easiest customer up to now. But what I found is that the team of Jones Manville always answered my questions and in a practical way. So the product now is becoming on a level that it is really marketable for us and doing what we wanted to do.
Well, thank you, Jan. And with this, I give it back to Benjamin.
Wow, thank you, Jan and Danny. That was really interesting. I'm wondering more about Neomera's development history and about the technology. Maybe we could welcome Dr. Dana Milaoga online. Dana, do you think you could provide some insight on this?
Sure, thank you, Benjamin. It's a pleasure for me to talk about that. As Danny mentioned earlier, Jones Manville is a leading global manufacturer of glass fibers, and we are known in the world of composites as a manufacturer of reinforcement. So our fibers team actually has monitored closely in the last decade, maybe, the trends in the industry, and what they were consistently seeing is an increased demand in fibers for thermoplastics. The key drivers here were lightweighting and also sustainability and the concerns about the life cycle and the end of the life of products. So at the time when Danny came to our team at the technical center in Colorado, describing the problem that Agesia was having and their tremendous interest in approaching this with thermoplastic solutions, we were actually working on scaling up a new technology for producing thermoplastic composite sheets, Organosheets with polyamide 6. So we were working on that. Organosheets were already starting to be adopted in automotive application. At that time, higher end applications. So we're seeing polyamide 6 organosheets in Volkswagen brake pedals. We're seeing polypropylene organosheets in some door panels that Ford was manufacturing in large volume. So the automotive market was moving into that direction. And this is where we are also collaborating with other companies in the value chain to really see potential and to explore prototypes and to develop case studies around our new materials. So at the time, we were working on forming organosheets into seat pans or differential covers. We're discussing with equipment manufacturers about overmolding. So we have some examples here of very interesting demonstrators that incorporate our materials. Moreover, we were also working with a very agile engineering firm in Munich on developing concepts around our materials. So we were at the point where we built a full case study around a structural battery enclosure centered on polyamide 6 organosheets. So our whole work was around automotive. And as you imagine, automotive applications, as you know, take a long time to go from initiation to the time when a new material is adopted and you see it in a new vehicle. So when Dani came to us with Agesia's problem and the idea, that was exciting for us. And it was exciting for two reasons. One was time, right? So here was a customer who was interested in trying our material, and he was interested in trying it now, and he was willing to give us feedback right away, and very genuine and very solid feedback on the performance. So that was very exciting for a time perspective. Another aspect of our excitement was about the technology, right? So as I said earlier, we were scaling up this new technology. So our strength is that we're making the organosheets in a continuous process. So I'll talk about that in a minute. But at the time, we were able to really make large organosheets in a continuous process. So the length wasn't an issue. And you saw those panels; they were large, right? So the length wasn't an issue. We were demonstrating the width capability up to 1.5 meter. So those were two things that we were in control of. One barrier that we didn't break yet at the time was really achieving the right thickness. So the organosheets that you have seen in the application that Dani and Jan were describing are 3 millimeter thick. So this is an example here. I hope you can see it. It's a 3 millimeter thick organosheet, and we're making this in a continuous process in one step. And at that time, we didn't break the 3 millimeter barrier. So it was exciting for us to try that as well, and to try it quickly. And this is how we do it. Can you please highlight the slides? Thank you. So the JM technology is innovative, and it's innovative in the sense that we are creating organosheets not by using conventional melt impregnation, but by forming the polymer in situ, in place in the reinforcement. So the schematic here to your left shows a roll of glass fiber fabric that we take as a raw material, and then we impregnate with a low viscosity caprolactam, which is the monomer for polyamide 6, the precursor for polyamide 6. And we polymerize the caprolactam anionic in situ in the fabric. So this is happening at a low reaction temperature, so below the melting point of the polymer. It's a very clean reaction. There are no byproducts, nothing that can evolve and generate voids during the process. And we obtain high molecular weight polyamide 6. It's a high throughput technology. And what's interesting and what makes it really suitable for high volume application is that because we're starting with this low viscosity monomer, we can impregnate very thick layers of fabric. So we reach up to 3,600 grams per square meter. So in order to create that 3 millimeter organosheet that you saw earlier, we start with a couple of layers, so 2 or 3 layers of fabric that we impregnate at the same time. So the polymer is forming this structure. There's no risk for the lamination, and this is why you're seeing the good performance in that open, close, and in a sense fatigue cycles that Jan was describing. So this is how we break the barriers by innovating, and that's a technology that has been developed at the Jones Maverick Technical Center in Colorado. It's a proprietary technology. So anionic polymerization is not new, and people have been doing it for decades. But what Jones Manville does differently is that we do it in a continuous process. And this allows higher throughput, and it makes the organosheets more affordable and actually more accessible to other applications in other markets than automotive. And that's what we are very excited about. This is how we do it. And I want to highlight where we're taking this next. So based on the technology, Jones Manville is moving into the space of composites. And our team in Colorado is constructing a full portfolio of polyamide 6 organosheets that are made by in situ polymerization. And I'll pause here a little bit to talk to you about what's different and what's versatile about this portfolio. So as I mentioned, the matrix is always polyamide 6, but the fibers here can be glass, as we talked about. It can be carbon as well. They can be aramid or hybrid. So the technology is pretty much fiber agnostic. It allows us to expand into other reinforcement. Another thing that's interesting is the fibers and how they are arranged, right? So I was showing earlier a schematic showing a glass fiber fabric. The fabric can consist in, can be woven, right? So you can have a woven construction. You can have a non-crimp construction, which is very unique for JM. And the technology has also been demonstrated for chopped rovings. And what's interesting is that because this portfolio is so versatile, design engineers can choose an organosheet construction that's appropriate for their application. For example, if somebody wants the highest stiffness, highest strength, and highest formability, probably a solution would be non-crimp fabric organosheet. But if formability is key and you don't want to maximize strength and stiffness, a chop roving organosheet might really do a very good job and save cost and maybe save weight as well. For the Agesia application, what we choose is an organosheet that's in the IG6 series. In this construction, the fabric, the glass fabric, is a 2-2 twill. So half of the fibers are in one direction, half are on the perpendicular direction. So we have a series of layers that are impregnated in one step. So that's a woven construction, and we needed that because of the type of load that those panels were seeing. So that's what we're excited about.
Thank you, Dana. A quick question. In your technical opinion, why are GM's organosheets the best product for this application?
So for the Agesia application, they are really appropriate because, as you saw, they do the job, right? They fulfill the requirements. They can withstand the type of load, and they're also cost effective. So the way we make them makes them cost effective and then performing because they don't delaminate. But in general, we like to talk about the advantages of JM organosheets as being, in a way, composite advantages themselves, because I mentioned earlier we have advantages that come from the fiber. There are various types of fibers that can work with our technology. There's various isotropy that can be built from the fibers themselves. And we know that they have advantages. So the organosheets have advantages coming from the polymer. As I said earlier, it's produced in situ, it's high molecular weight. And what's very interesting is that this PA6 has never seen an event that can lead to thermal degradation. So we are making it at about 150, 170, maybe in that range degrees Celsius. And melting is over 210 to 120. So this polymer has never been melted, has never been degraded. So that's a huge advantage. And what we really like to talk about when it comes to glass is an added advantage that we have as a glass manufacturer. So for glass fiber reinforced organosheets, JM is using fibers that are made with JM reactive glass technology. So that's a proprietary sizing that allows the polymerization reaction to start from the glass surface, so that at the interface between the glass and the polymer, there is a strong covalent bond that leads to additional advantages, better shear strengths, and ultimately helps with those fatigue cycles. So those are the advantages that come from components. But in the end, what matters to the customer is how the sheets behave, right? And our organo sheets are easy to use. They don't have a limited shelf life if they're stored appropriately under regular temperature and humidity. So they are easy to use in automated processes. They're lightweight, and nevertheless, they are thermoplastics and they're recyclable. So here I would like to actually get the mic back to Danny and let him comment on why this is important for our customers and for our customers' customers.
Well, recyclability is very important. It's all over these days. So the first question what we get when we I ask a customer to test our product, they ask about sustainability. What can we do with the product? Is your carbon footprint under control? Is it lower than other products in the market? And what do you do for the future? What are you going to work on? So most of the time we can answer these questions because we are recycling, for example, already a part of our own waste in the glass manufacturing process, up to 8%. What we also do, and in case of the organo sheet, it's very easy. An organo sheet is a continuous material with continuous reinforcement. It can be reused in another application. If it's a big panel, they can cut small panels out of it for other applications. But most of the time, it's better to grind the material into small pieces and use it as a injection molding material to reinforce, for example, the same organo sheet, which is overmolded. So there is a continuous cycle possible with the material, but of course, if you break down the continuous rovings which are in there, you cannot make the same organo sheet out of it anymore.
Thank you very much, Dana, Jan, and Danny for this great presentation. I think it's now time to open the floor to questions, and I see that we already have a few in the question tab, so thank you very much. I can see that Michelle from Jones Manville is also answering live from the beginning. Thanks very much for this. If you have any further questions, it's now, so don't be shy and ask all your questions in the question tab on the right of the screen. But before we start with the first question from the audience, I have 3 questions that I would like to ask you all. Maybe the first one being for Danny, sorry. What other markets is the product a good match for and why?
Well, for example, sporting goods can be a nice market, but we developed the product for metal replacement. And if you think about metal replacement, where is the biggest market? It's automotive. And with the launch of the EVs, the electrical vehicles, which come quickly on the market now, we see an increase in weight of these vehicles. You can increase the battery package that you can drive longer distances. But that is most of the time not a solution because you're adding weight. So taking out weight of the future electrical vehicles, that's our goal. And I think we have the right product for that to succeed and to be present in that market.
Thanks, Danny. My second question would be more for Dana. What type of new products will Jones Manville be developing over the Neomera platforms in the future?
So Jones Manville, as you can expect, is starting with glass fiber reinforced organo sheets because glass is our strength and we're innovating on fibers and we're innovating for glass fibers. We're starting with woven glass fiber reinforced organo sheets in the OS6 and IG6 series that we presented earlier. We'll continue to explore the chop rovings, but we are having our eyes on carbon as well, and we demonstrated that our technology works. So that's how things will progress, but starting from glass and starting to innovate from fibers.
Okay, thank you. And my very last question, how can the audience get more info on Neomera?
It's very simple, Benjamin. We have a slide with our contact details on it. But I would invite everybody who has time to come over to the Fakuma, which takes place next week from Tuesday until Saturday. And we have a booth over there where the Jones Manville personnel can help you explaining the product and answer most of the questions you could have. So we are in Hall 2 at booth 2215. So don't hesitate and come visit us there. And I will be there as well.
Thank you, Danny. So let's move with the first question from the audience. So I'm going to the list. Okay, we have a question from Stefan Lehmann, who is asking what is the maximum fiber content in the material?
So we are, it depends, of course, on the construction. So if we talk about glass, usually for the woven organosheets in the OS6 series and IG6 series, and for the non-cream, we are around 65 to 67% by weight glass. For the chopped rovings, the glass content, as you can imagine, can be tailored, and we are exploring between 40 and 70% by weight. And we're talking glass here.
Thank you, Dana. Next question is from Guillaume Normand about recyclability. How would you manage recyclability? So I know, Danny, you talked a little bit about that. Would you separate fiber and matrix?
In this case, it's not necessary. When it is a first cycle of recycling, it's not necessary to separate that. Of course, it's possible to use a chemical separation process, but that's very intensive. I think there are better possibilities to use the material. And like I described it, injection molding of grinded material, it doesn't matter. It is during the cycle that you produce the part and the cutoffs, but it can also be recycled after certain lifetime. So there is no problem that the product will not lose a lot of its properties by using it in an overmolding applications. And actually we have nice figures of that because we were comparing it with short glass fiber compound in 10 and 13 micron. And knowing that this direct roving, which is used in this application, is 16 micron, we even beat the properties of a 10 micron, 30% or 40% filled glass compound. So I think there is the proof that recyclability is perfectly possible.
Thank you. Next question is from Wouter Winant, who would like to get more information about the adhesion between the PET foams and the PA6 organosheet. Is it direct welding technology, thermosets adhesive, or thermoplastic adhesive?
Certainly not an adhesive. I cannot reveal too much about this. We will be ready to reveal more on the thermoplastic convention in San Diego in February, but it is a molecular binding. It's a covalent binding. We call it CEB, covalent intermediate bonding. So it's always difficult to talk about welding or bonding or gluing, but this is definitely a covalent bonding. And it's patented.
Okay.
But I cannot say more.
Perfect. We have last question right now. Don't be shy. You can ask again all your questions. I know that Michelle is answering so fast by writing that we missed some questions. Next question is from Kazuaki Nishuyabu. Sorry if I misspell your name. It should be noted that the PA6 composites is large and the elastic modulus and strains are greatly reduced due to the water absorption. How to deal with it?
That's a very good question, and as you expect, we're getting it a lot. Indeed, polyamide 6 is absorbing water, but these composites, this answer relates to the previous question, where we're looking at composites that have up to 70% glass, so it's only 30% of the composite that's polymer. And a lot of the properties are dominated at that point by the glass. So for some applications, yes, water absorption is an issue, and we're not going to go there. We're not going to probably put these organosheets in marine applications necessarily, but due to the high glass content, we are very successful in a lot of others.
And I think we can add something to that because Jan just received yesterday test results of this panel that he was putting in water at 60 degrees Celsius. And Jan, maybe you can explain what happened with the panel.
Well, we didn't see a lot of differences, but I did a lot of testing with Organosheets in water to the anger of my wife overall. Using kitchen pots with thermoplastic material is not exactly the right thing to do, but I found very good values. So the water absorption in the product that I use now is not more than the water absorption that I use with my vinyl ester product. But more data will be available once these lab tests will really occur. Also that we will discuss in San Diego in a couple of months.
Thank you. We have a question from Eckhard Ries at Ries Solution in Germany, who is asking, could you say more about the CO2 footprint?
Well, I'm proud of that because the plant where we produce the roving has the lowest CO2 footprint in Europe. I don't know about the plants in other locations like America or Asia, but in Europe we are definitely the lowest. And we have these numbers because they are published in a document which is available by Glass Fiber Europe. So there we know who we are and we can compare us with the data from competition. We don't know exactly the other numbers, which competition it is, but we know our numbers and we see where we are. So that's number one. We have recycling of our own waste in the furnace. We put up to 8% of recycled material from our waste. When we start up, when we clean the material from the roving, etc., we grind it and it goes back in the furnace. So that's the second point. And the third one is because we are making the material starting with caprolactam, which is a monomer, and we start the reaction at 150 degrees, it's way under the melting temperature. And the fourth one is we don't consolidate, so we don't need extra heat. So it's a one-step process at low temperature, and if you know where the roving is made and that is already lower than any other roving in the market, then I would say I think we are very well established to have a good product with the lowest carbon footprint from that kind.
But if I may add, you also run the product through the eco calculator of UCI with excellent results, and one day we will publish them.
Yeah, that's right. Yeah.
Great. Another question from Warden Chivri is asking, how do you recycle the sandwich from PET and PA6 glass fiber?
Hello, Warden. Good to see you here. That question actually is more to Agesia because, as Jan said earlier, the adhesion between the Organosheet and the foam is proprietary. So that's an answer that they are approaching. But thanks for asking. I don't know, Jan, if you want to comment on that.
No, you gave the perfect answer.
Okay, great. We don't have any more questions so far that hasn't been replied. Michelle, yes, we have another one. Okay, so Eckhard Ries, who asked just before to say more about the CO2 footprint, he's asking if you can send the data sheet of the CO2 footprint.
We used the eco calculator from UCI, but the full process for making a product with caprolactam is not in there. So that it needs to still to be developed. So I was using other tools which are similar to it to come to the carbon footprint. I don't say it's exact, but it gives you a perfect view on where we are. And then I compared with the traditional melt impregnation or film impregnation, where you need the heat to put in the thermoplastic, and then to bring the several layers in consolidation together. So every time when you have a heating step, you add a CO2 footprint. We don't have that. The first heating step the product is seeing is at the customer. Nothing else is happening here. We are starting our reaction, like Dana said, at 150 degrees, and we don't go higher. And PA6 is melting normally around 215 to 220 degrees. So if you know that there's already 70 degrees difference, I think it's clear that we don't put a lot of energy in there to make the material.
Thank you. So I'm asking the audience that this is their last chance to ask questions. Do we have people thanking you for a very interesting webinar. Thank you very much for this. Another question pop up from Manville, who is asking, do you also produce PET or buy from your customers?
We don't produce PET organosheets. But if you ask about the foam, I need to direct it to Jan. He can give an answer on that.
But what was your question?
The question is, do you also produce PET or do you buy it from your customers?
We buy it from our supplier. So we're not a big company. So making PET is something different than making a panel. So we buy the PET of the market.
Okay, thank you, Jan. Another question from Sian Kamisli. How about PP, polypropylene?
Well, I can answer that. At the moment, we don't do anything with polypropylene because we start with reactivity from the glass. And polypropylene as monomer still not existing. So it's very difficult to work with that and to use the same way of impregnating the fibers and make an organosheet in one step, for example, from 3 millimeters. So polypropylene, as far as I know, it still needs to be done by consolidation and by melt impregnation of several layers and then make the final product out of it. So at the moment, as the technology is not existing, we don't do it.
And polypropylene, the heat resistance is too low to use it in structural applications. So it's merely used in walls and roofs, but never in really structural applications, because once you reach 60, 70, 80 degrees, you will have creep or plastic deformation.
Especially in the big panels that you use.
Yeah. For us, it's not an option.
Okay, more questions coming. We still have time for this, so that's great. Rien van den Acker, who is asking, in principle, you can also pull through with this technology. Do you plan that?
I have done trials. I have done studies on pultrusion and proven that it's possible to have it done. So, in fact, the idea started first with this reactive material to work with RTM or TRTM or T-rim by bringing a fabric in a mold, impregnated it in a closed mold, and impregnated with caprolactam, let it react, take out the part, and do the new one. So that was the first step, what we did in the past. We tried to bring that to the market, but the market was not ready for it. So the next step we took was a continuous process, and that was the pultrusion. So we did it with a partner in the university, and we tried to do that to prove that it was possible. And we proved it. We had many challenges, that I can say that, but there was the proof that we could make beams out of it. We didn't use a difficult shape. It was like a rectangular part which was coming out like 7 centimeters wide and 1 centimeter high. And for the rest, we were using the same rovings which are used here in that organosheet, what is in front of us. And based on that, we start thinking, what are the next steps we could do? And the next steps was continuous impregnation for making organosheets. And who knows what comes next, because maybe there are other technologies what we can use to use the same ingredients to make parts which are products which are not existing at the moment.
But if I may add, call it pultrusion or call it whatever, a continuous process to make beams and profiles will be a necessary step to push this product forward. We will now form beams because they're not available in thermoplastic material, and we do not combine thermoset pultrusion with this thermoplastic material. So this is a very big step that is still to be taken, and the glove is laying on the table, so pultrusion companies start working on it.
Well, it's maybe something for the APTA conference next year,
why not?
The week before the GEC in Paris. So
it's a challenge, and it will come, absolutely.
Great, thank you. Next question is from Unai Morales, technical one. What about the hybridization of Organosheets glass fiber PA6 and 3D printing reinforced insert based also in PA6? Do you have any info about the adhesion quality if you try to print over the Organosheets?
That's an excellent question, actually. And then it has two parts from what I see it. One is about the hybridization of the Organosheets with glass and carbon, and we prove that. So you can feed, for example, for fabric-based Organosheet, you can feed 3 layers of fabric and sandwich maybe a carbon fiber fabric between 2 glass fiber fabrics and create a hybrid composite. So that has been demonstrated as long as there's nothing on the carbon fiber that prevents polymerization. So if we use the right fiber, that's possible. So we prove that. For the second part of the question, is the way I see it, the question is about 3D printing reinforced inserts based on PA6. So our PA6 is fully compatible with polyamide 6 and glass fiber and carbon fiber reinforced polyamide 6 that's used in 3D printing and in injection over molding. So the adhesion is excellent because you get a fully fusion bonded interface between the Organosheet and the added material, whether that's added by 3D printing or it's added by injection over molding, as long as the processing conditions are appropriate. So this is why, if you remember in the beginning, we're saying that we're working with companies in the composites value chain to see where our materials are going in and to understand what other processes as those Organosheets are subjected to. So the answer is yes, good quality.
Any more comments from Danny on this? No? It's okay. Okay, last question I have from Eckhart Breeze is asking, could you realize the foam also in PA?
I think that would be possible for other applications, but Jan is the specialist in that, in sandwich panels, so I'll hand over the question to him. But in principle, it is possible.
Well, if you say it can be done, it must be investigated. But we are very much satisfied with the high-density PET foam. And I did a lot of work in testing different foams in my life. And for the moment, PET foam and high-quality PET foam, high density, is the best solution for what we have here. But never say never. But so I have no experience with PA foam. So
but for automotive applications, if you want to have full recyclability and you have a PA foam, what you inject or what you use as a part where you start sandwiching with Organosheets, it will couple directly, and you don't need an interface product to it, because these products are basically out of the same product, and they will couple immediately without any adhesive in between.
Okay, thanks very much for your answer. I think we're running out of question and of time also. So we have now come to the end of this event, and I would like to thank everyone for participating and for your great questions. Don't hesitate to get in touch if you have more questions. You have the contact details of the panelists on screen, so don't hesitate to get in touch. I hope you enjoyed the time with us today and that you have learned something about Neomeras. I want to thank Dana, Danny, and all the teams at Manville, as well as Jan from Agesia, for their participation today. Thank you very much. The webinar was recorded and the link will be sent to you immediately, together with the link to download the presentation. We look forward also to welcoming you next month for our next webinar with Armacell on November 9th at 4 p.m. CET. The webinar will introduce how Armacell's innovative range of the world's first particle foam based on 100% recycled PET offers solutions for waste-free molding of complex 3D shapes. You can get more information and register for free as usual by visiting our website on geccomposites.com. Thanks again very much, and see you again soon.
Thank you, Benjamin.
Thank you, Benjamin.